Okay, good going, good going. Okay, good going, good going.
And then we discussed about the structure of the computer, function of the computer, and last class we discussed about what is multi-core computer and what are the functionalities of a multi-core computer. All the things we discussed, right? So in one second. See, our class timings is it is Thursday 9:30 to 10:30, Friday 10:45 to 11:45. This is the timing that we are following. That already I told in last to last week itself. Already I informed. Last week also I told. Only yesterday class it got cancelled because of power is not there and I was not able to connect because of internet issues. That's the reason yesterday class was not there, and today I connected it. Okay, so the timing is same at least till this week. If they are coming up with the new schedule from Monday, we'll see. Because as of now, I didn't receive any information regarding new timetable from Monday. So I'm not sure. Are we going to follow the same timetable or some other slot we will get? I'm not sure. So I'll check, and after that, I'll let you know. Or else the timing is the same only. Okay, as I already told, Thursday and Friday will connect. Thursday 9:30 to 10:30, Friday 10:45 to 11:45. This is our timings. This one, okay. So any information you got regarding Monday's thing? Anyone? From Monday, are we going to means? Actually, I'm on leave for almost 10 days, so I don't know what is happening there. But I get to know that there are preparing lab slots and all the things. So if you got any information regarding timetable and all, please let me know. Okay. So anyone who got information about new timetable? Any idea? Any idea about how classes are going to be happen from Monday onwards? No idea. No one knows. Okay. Okay, fine. If I get to know any information, I'll pass to you. Okay. Because as of now, I didn't receive any information, so I don't know. Uh, so if this is the thing, I will continue with the same schedule, Thursday and Friday. Meanwhile, from next week, we'll start. We have to start labs because our theory session that we are going to come to the end of the chapter 1. So once the theory for that lab is done, then we'll step into the programming. Okay. So till that time, we'll be having theory classes. Maybe by next week, we can start our labs. Okay. And the option I had given for lab is online only, because I got the feedback from many, like a few of your friends had sent me WhatsApp messages privately as well as in the group also when we are discussing. You prefer online mode, so that's the reason I had given preferences online mode for the lab also. I'll okay. I'll make the videos as well as I'll share the PPTs also related to the lab things. Okay. So after that, well, start. And regarding MS Teams, maybe from next week I'll start, because even I have to actually I have to get all the things configured there, and since I'm taking it from home, my laptop, it is like not I didn't configure mine with MS Teams because I'm using only Linux. So I find it difficult to configure it here. Maybe from next week I'll try to take from Teams. Okay. So all the comments are addressed, right? I will we'll start the class today. So the first thing is history of computers. So in today's class, we are going to discuss about the history of computers. Already from the school, you studied about all the histories like first generation computer, how it was, and all the stories behind it. Second generation, third generation, fourth generation. So all the things would have studied from the school, like what it is doing, how it is doing, the theory part. But in today's class, what we are going to discuss about the architecture part. Okay, it's not about the organization, it's about the architecture part. As I already told, there are two things. One is architecture, one is organization. So what is the architecture means? What's computer architecture means? Somebody raise the hand. Who is that? Who had raised the hand? Okay. Okay, what is architecture means? Anyone? What is architecture means?
Like how
What
the
is
computer is built.
Hmm. How the computer is built? That's architecture. Okay. Anyone?
Attributes that are visible to the programmer.
Yes. Yes. Attributes that are visible to the programmer. So how a programmer sees a computer? Yes, good. And how a programmer sees a computer, that is architecture, correct? In today's class, we are going to discuss about the architecture of the very first computer. That's the first generation computer. And then we will relate the architecture with the recent computers. Okay, and I'm not going to take the theory what we studied from the school and all, how it is different data, how it is processing the data, everything is same. Okay, all the stories we are not going to study today. We are going to discuss about the architecture part of it. Okay, so the first generation computer used vacuum tubes for the digital logical elements and memory. For all the things are designed using the vacuum tubes, and they call the first generation computer as IAS computer. Okay, it's a first generation computer. They call it as IAS computer, and the design approach implemented in the IAS computer is called the stored program concept. Okay, we call this as the stored program concept. Okay, and all the things are designed by John von Neumann. Okay, so this idea of the first generation computer is proposed by John von Neumann. In the same time, there is one more scientist named Alan Turing. He had also come up with a similar idea. Okay, but the first generation, but the first patent had come to John von Neumann because he had come up with this implementation and all the things. Okay, so 1945 in von Neumann, and he called the computer as electronic discrete variable computer. Okay, and the IAS computer, it is a prototype for all the general purpose computers. Okay, so what are all the recent architectures that we are following also follows this IAS computer architecture. Okay, so in today's class, we are going to discuss about this IAS architecture. This is a first generation computer, and it is design approach is called a stored program concept. This is proposed by John von Neumann in 1945. He called this as electronic discrete variable computer. So first, we all know the purpose of the computer is to do some computation. So the computation can be an arithmetic operation or the logical operation. So the first purpose of the computer is to do arithmetic operations. To do arithmetic operation, we need an arithmetic and logic unit and registers to hold the operands, and we need a memory, and we need the input output, because we are getting the input from the external environment and we are doing some computation and giving the output to the external environment. Correct? So the first functionality of a computer is arithmetic and logical operation or the computation. So the first thing is let me go. The first, it has to perform arithmetic operation, and the part that performs arithmetic operation is called as central arithmetic part. In the figure now you can see there is an arithmetic logic unit, that is arithmetic and logic circuit, that's ALU, and this AC stands for accumulator. Okay, AC stands for accumulator. It is a register that is used to hold the operands as well as the result. Okay, again I repeat, AC, it stands for accumulator. It is used to hold the operands as well as the result. And what is this MQ? MQ stands for multiplier quotient, and it is a temporary register. Okay, MQ stands for multiplier quotient and it is a temporary register. As I already told, ALU, that is arithmetic and logic circuit, it performs arithmetic and logic operation. So to perform the operation, it needs the values. The values can be from our accumulator or from this multiplier quotient register. After that, this arithmetic and logic circuit store the results in MBR. MBR stands for memory buffer register. Okay, MBR stands for memory buffer register. And you can see from this figure, it is connected to the main memory. So MBR is used to hold the data or a word that has to be sent to main memory, or it is used to hold a word that is received from the main memory. It is bidirectional, right? So MBR, memory buffer register, it is used to hold the data received from the main memory or data to send to the main memory. Okay, it is used to hold the data. Data are placed in this MBR register. If you want to send the data to the main memory also, we have to hold it in MBR. If the data is coming from main memory also, we have to store it in MBR. And you can see here, the MBR is connected to input-output equipment. So MBR also contains the data to send to input-output. Okay, if you want to send any data or word to the input-output, then we have to place it in MBR. And if you want to receive any value from the input-output, that also be placed in MBR. Okay, so I'll explain. MBR stands for memory buffer register. It contains the word. See, data or word, both you can use. It contains the word to be stored in memory. Point 1. It contains the word to send to IO. Correct? And it is used to receive a word from the memory, or it is used to receive a word from the IO unit. Okay, so MBR functionality is 4. If you want to talk to main memory or to input output through MBR only, you can talk to. Okay, all the recent computers also have this. Okay, memory buffer register, similar type of architecture is there. Okay, so if the question is, Okay. If the question is like explain MBR, so first you have to write MBR stands for memory buffer register, and it is used to all these 4 points you have to write. Okay, contain the word to be stored in the memory, contain the word to send to IO, used to receive from IO and the memory unit. Okay, and next explain accumulator or multiplier. MQ I told it's a multiplier quotient. So it is used to hold the result of the ALU operation or temporary operands. Accumulator is used to hold the result of the ALU operation or temporary operands. Okay. So these two registers are very important. You have to keep in mind. Okay. In the central arithmetic part, accumulator is a register we are using, hold the result, and temporary operands. Multiplier quotient also hold the result or temporary operands. And MBR, the functionality we had studied now. Okay, and then we'll discuss about main memory and input output in the next part. Okay, so this is the important thing, the central arithmetic part. So the second functionality that the computer has to do is the proper sequencing of the operation. Okay, so it is done by the control unit. How the proper sequencing is happening, that is the second one. So to do that, we are having multiple other registers that we are going to see now. So program control unit, for that the registers are the following. I told no, it's an MBR, memory buffer register, PC, program counter, IBR, which is nothing but instruction buffer register, and then IR, instruction register, and control units. Okay, so the functionality of the every register I am going to explain now. So I repeat, the second functionality is nothing but the proper sequencing of the instructions. So which instruction has to go first, which instruction has to go next, that sequencing is done. Okay. Yeah, we can record. Maybe from next class we'll try that option. We'll record and then share. Okay. Because Zoom, this option is actually it is we tried in Zoom. Since ours is like a free version. Even in college, what we are using is the free version. We cannot record it. It is not allowing us to record. Maybe that when we start using Teams, that is probably next week. I have to get it configured, and after that I'll start. From that time, we'll start recording. Okay. And another thing, it is like whatever I am taking is directly from the book only. I already shared the first page of the book, 10th edition, Computer Organization and Architecture, Designing for Performance. Author is William Stallings. That's the book that we are following, and whatever I am teaching is from the book only. Whatever the syllabus we are taking is also from that book only for the theory thing. And for the lab thing, there is one more book, that's a professional assembly language by Richard Blum. Maybe everything I can share. I have to check the soft copy and I can share with you maybe on Monday, because I have to check in my desktop whether I had this soft copies and all. That's the reason I'm not able to share. Okay. And another thing, yeah, even I'm getting messages like they are not able to connect because of network issue. I don't know that person. He's just sending messages. His name is not coming, so I'm not sure who is he or she. I'm not sure. Yeah, it's fine. It happens. but please try to attend classes. Uh, uh, at least some 40 percentage will get into you by listening to all the things and remaining and after reading you will get the remaining things. Okay, so please try to. Okay, yeah, sure. Ma'am, I have downloaded both. Can you just check if it's the same and then share with the others? Okay, sure. Can you please send it to me so that I can verify it and we can share with others. Okay. Thank you. Good. And all these registers we are concentrating, no? So all these registers function, either the functionality of the register or who is doing Nitish, either the functionality of the register. One second, Nitish, you are not supposed to. Is very important. It's a gate level questions, and even in exams also 100% one question will be based on the registers and its functionality. Okay, there are so many registers. Till now we studied MBR or accumulator and multiplier quotient. Another 4 or 5 registers we are going to study now. So after studying all the registers with the functionalities, you have to remember it properly. That is very important. Okay, because most of the time definitions, everything will be correct, but perfectly you will write in a reverse way. If I'm asking for program counter, you will write the instruction register functionality. But it is wrong, no? So we cannot give marks. That's the reason I'm saying, please, when you're studying itself, the register name related to the functionality, the name and the functionality are related. Okay, if you understand this concept, then it's very easy for you to remember the things. That's the reason I'm doing these things very, very slow. Okay, so now we are going for, we discussed memory buffer register. Next thing what we are going to do is we are going to do memory address register, MAR. M stands for memory, A stands for address, and R stands for register. Memory address register. Okay. So it specifies the address in the memory of the word to be written from or read into MBR. Okay, as the name itself says, it specifies the address. Which address? The address of the word. Where it is stored? It is stored in the memory. Okay, so it specifies the address in the memory of the word. Okay, so in the address, some data is there. Where we have to store? We have to store it into MBR. Correct? No, memory buffer register contain the data or the word. Correct? So, if you want to read anything from the memory, we have to place the address in the memory address register. Suppose I want to read from the location 1004. So I have to write like read 1004 to the memory address register. The memory address register contains the value 1004. After read operation, the value in the location 1004 will be placed in the memory buffer register. Okay, this is the meaning of it. Memory address register specifies the address in the memory of the word to be written from or read into MBR. Okay, so now memory address register is done, and next we'll see the IR. I stands for instruction, R stands for register. I stands for instruction, R stands for register. IR register. IR register contains the instruction being executed. If you are executing some instruction, where it will stored? It is stored in instruction register. As the name shows, IR stands for instruction register. It is used to hold the instruction being executed. Okay. And the next thing is, so we studied MBR, IR, MAR, and the remaining thing is PC and IDR. So first we'll discuss about PC, program counter. PC stands for program counter, which contains the address of the next instruction to be fetched from the memory. Okay, so it contains, program counter means it contains the address of the next instruction to be fetched from the memory. Okay, so it contains the next instruction address. So this next instruction address, we have to place it in memory address register, and the memory address register, whatever it access the memory and whatever the value in that will be placed in the memory buffer register. Okay, and the next is instruction buffer register. It holds the right hand instruction from a word in the memory. Okay, so in this is the, we are not using instruction buffer register nowadays, because in the old architecture at a time, and there are two instructions are possible. So this instruction buffer register holds the right hand instruction from a word in the memory. I'll show you what is the meaning of this. So this is the, see, don't play on the screen. Don't play on the screen, okay? This is the format of the instruction. Okay, so the instruction format is, it is 40 bits. Okay, so first 8 bit is for the opcode. The opcode is nothing but which operation it has to perform, that's the opcode. And the next 12 bits is nothing but that's the address designating word in the memory. If it wants to access memory, that address is here. This is the left instruction. This is one instruction. Right hand side is another instruction. Okay, so earlier the instruction format, it is, the instruction is of 40 bits. First 20 bit is for first instruction. Next 20 bit is for next instruction. Okay, so in the first 20 bits, 8 bit is for the opcode. That is nothing but what is the operation it is going to perform. And the next 12 bits contains the address in the memory. If it want to access any memory, then that address is there in the next 12 bits. Similarly, the next 8 bits is for the second instruction. That is which operation it has to perform. And the next 12 bits is for the address designating word in the memory. The second instruction, if it is going to access any memory, then those things, those address are in this last 12 bits. That's what it is given, left instruction and right instruction. Okay, so the right instruction is, this is the right instruction. So whatever it is, here it is, this is the right instruction. Okay, wherever the cursor is getting moving, and this right instruction is stored in the instruction buffer register. Okay, it is stored in the IBR, instruction buffer register. And then so all the registers we studied, right? It is the control unit. The second part is the sequencing operation, which is done by the control unit, and it is using all these registers: memory buffer register, instruction buffer register, IR register, memory address register, and program counter. Okay. So all the registers we studied. Now the third point is the memory. Okay, we are going to discuss about memory. That's a third important thing, or the functionality of the computer is the memory. So now, okay, now I will check. What's the size of this memory? The participants of more. What is the size of this memory? Hey, anyone? What is 4096? What is 4096? Do I have to call? Every day if I call the same person. Yes, somebody is volunteering, please. No. Okay, roll number 36. Divyansh. No, okay. Then, okay, Nandan, 20, BV Nandan, 23. Hey, roll number 23. Get up, get up. 23, sending some message. No. Why no? You don't know the answer. You don't know the answer, Nanda? What happened? No, ma'am. Yes, ma'am. Okay, anyone? Hey, that day we discussed, no, what is 4096?
Ma'am, 4 MB.
No. 4096.
4 KB.
4 KB? Okay, how it is 4 KB?
2 to the power 12.
Okay, 2 to the power 12.
And
It is
2 to the power 2 plus.
What's your name?
Yes, ma'am.
What's your name?
Anubhav.
Oh, okay, roll number 19. 19?
19.
Okay, good, correct. That's the answer, 4096. See, it's 1024 into 4 is 4096. What is 4? It is 2 power 2, no? So it is, which is nothing but 4 KB. The answer is 4 KB. Okay. And another thing is, this 4096 words. Okay. So we'll see, maybe after some classes, we'll discuss what is a word and what's the size of it, all the things. But approximately now you know that given a memory, you can say that it is of 4 KB. Sorry, 4 KB or 2 KB? It's of 2. It's of 4 KB. Correct? 1 second. This is the answer. Okay. So now memory is done. The fourth important thing is the input device. Okay. How this central arithmetic and the central control is talking to the external environment, and how the external environment is talking to these two, which is nothing but the input and the output things. So the fourth one is input device and the fifth one is the output device. Okay, so totally there are 5 things. We studied the 5 important things of it. First it is central arithmetic. 1 second. We'll reconnect. It's going to end. We'll reconnect. (4096) words of 40 binary digits or bits each. Okay, it is having 40 bits each. Okay, earlier it was 40 bits. Nowadays it is either 32 bit or 64 bit, right? That time in the first computer it was 40 bits. Okay, and and the instructions and data are stored in the memory. And if in the 40 bit, the first bit, the MSB, is nothing but the sign bit, and the remaining 30 bits are used to hold the value. Okay, so this is not for the recent computers, this is for the IAS computer, that is the very first computer. Okay, and I already told you, no, the format of the instruction, it is having, it's capable of taking 2 instructions at a time. So left instruction, right instruction. Okay, and then we studied about this. The opcode is nothing but it contains what is the function that it has to do, that is given by the opcode. And if it wants to access the memory, that memory address is given in the next 12 bits. Okay, so all the things we studied. Okay, and next it is so this one already I studied what it is, what the components and all. Okay, so I want to ask you questions. 7 participants missing. They're connecting. Chaitanya, roll number 64. Chaitanya Chaudhary. Chaitanya Chaudhary.
Yes, ma'am.
Okay. Chaitanya, you can unmute yourself and please answer.
Yeah, yes, ma'am.
What does MQ stands for? What
Sorry,
is
ma'am.
MQ? What is MQ? MQ. Here, what I'm showing, no, this MQ. You are able to see my cursor, no? MQ.
Yeah, ma'am.
What is this MQ? Okay, Chaitanya, you have to listen. See, these are all the small things, but I don't know. In all the exams, we will ask. Start from term test 1 till the semester end exam, we will ask these registers. There are 6 or 7 terminologies, and will ask at least this for some 10 to 12 marks. We will ask. That's the reason I spend this much time to explain only this. Okay, but you have to listen. Okay, pa? Prajwal. Prajwal, get up. Prajwal is sleeping. Next, Praneeth. So no attendance for Prajwal. Okay. Praneeth. Praneeth is also sleeping. Raghav.
Yes,
Raghav.
ma'am.
Is this Raghav or Praneeth?
Raghav.
Okay, Raghav, what MQ stands for?
I don't know.
Hey, what is this? Okay, anyone randomly. Now I'm started feeling bad. Nobody is answering.
Multiplier quotient, ma'am.
Multiplier and quotient. Okay. So what's the functionality of it? Very good.
Functionality,
Okay.
ma'am, don't remember, ma'am.
Hmm?
Not remember, ma'am, that function.
Okay. MQ stands for multiplier
Used
and
to hold
quotient.
the result.
Yes, it is used to hold the result temporarily. Okay. Good.
Result of ALE.
Yes. What is AC? AC stands for accumulator. It is used to hold one of the operands as well as the results. Okay. And next, what is MBR? MBR stands for
Memory buffer register.
Register.
Memory buffer register. Very good. What is the functionality of MBR? I'll show. Just 1 second. Now look at the diagram and tell what's the functionality of MBR. Anyone? What is the functionality of
Holds the
MBR?
data that is received.
Yes.
Holds the
Very
data that
good.
is received from the main memory
Very
or
good.
to send the
Mm.
data to the main memory.
Very good. Next. Yes, one more.
Contains
Yes.
word to be
Yes. Yes, it contains the word or the
contains word
data.
to be sent to input output unit.
Yes, very good, very good. What's your name?
Sent to the Harshita
Your name,
Gupta.
please. Okay. Good, Harshita. So this is the MBR, function of MBR. It is, see, by look at the diagram, you can say it is used to hold the value from the main memory, or it is used to hold the value from the input output. If you want to receive it, or you can say that, see now, okay, you can read from here. Memory buffer register, it contains the word to be stored in the memory, contain the word to send to IO, used to receive a word from the memory, used to receive a word from the input output unit. Okay, this is the functionality of MBR. Accumulator, we studied multiplier quotient, we studied proper sequencing. Yes, what is in IR? IR stands for? IR stands for? I am getting messages. Who is that? Are you getting my notes? Because after classes, I'm sharing these notes in the group. And whether you people getting these notes? Say yes or no. Last 2 classes after my class, I shared it in the group only. You are getting these notes, right?
Yes, ma'am.
Okay, fine. So after this class, I will upload these notes. Okay. Yes, ma'am. Yes, ma'am. Good, good. Okay. So memory buffer register is done. Memory address register, as the name suggests, it is used to hold the address of the word. Okay. It specifies the address of the memory of the word. Okay. At least if all these lines you are not able to write, at least it is used to specify the address in the memory, or it is used to hold the address. This much itself is fine. Something is better than nothing. Okay. So when you are writing in exam, you have to be very clear in this concepts. Okay, and instruction register contain instruction. Program counter contains address of next instruction. Instruction buffer register hold the right hand side of the instruction. Okay, because there are 2 instructions are there. The right hand side instructions will be held in the instruction buffer register. Okay, so in the book after this, they had given one partial flow graph that explains this, all the registers they had given and that portion number, all the things they had given, but it is okay, there is no need to study the partial flow graph, and then they had given the IAS instruction set. Okay, so what are all the different types of instruction, all the things they had given, but we are not going to study that IAS instruction set. Directly we are going to study this professional assembly language, that is the Intel's instruction set only we are going to study directly. Okay, and the next thing is whatever we studied